All right, so welcome back. For the second part, I will be talking about the cloud part. So we have been looking at how it works technically from a physical side, how data center design is done, how the physical fibers are connected. Of course, there's also a big part in how we architected it to be ExpressRoute as it's called in Azure. Now, to be very clear on this, people think that ExpressRoute and the fact that we offer these types of connectivity, that it's something new. And of course, ExpressRoute as such is only known for the past 2 years, but actually we have been employing customers for more than 5 years already in this model. That before ExpressRoute existed, it was pure manual operation. So every time we had a customer and a customer said, I really need dedicated connectivity to the Microsoft backbone, it was really physical work to put all these patching in place, to really go into the data center in the meet-me room, patch all these ports, make the configuration, set up the routing, blah, 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 and make it happen. Now, of course, if you're operating on a huge scale, and that's what we call ExpressRoute. So that's basically the software component that automates everything that we did manually in the past. Now, the talk for today, I will be talking about the positioning of ExpressRoute. So why is it? Of course, it's crucial in our story. I will talk about the architecture, how routing works, because it's crucial in setting it properly in Azure, loosely from what the physical part is doing. I will look at some more advanced capabilities, what you can do outside of the normal next finish approach. I will do a demo to show you how you set it up. And then we talk about what if you need an ExpressRoute, how do you get started? What are the steps that you need? What do you need to keep in mind? What are the things that can go wrong? You name it. Now, for people who don't know me, I'm Kristof. I'm a Technical Evangelist at Microsoft in Belgium. And I've been involved in, let's say, in the past 2 years in almost all the ExpressRoute deals that we did. Some together with the guys from Cult. But I was also responsible for the design of the ExpressRoute offering for Proximus and Telnet. So that's what I do at Microsoft. So if you have any question about how does it work, how does it fit into the architectures you have specifically for Azure, let me know. Now, to drill into it, why did we create ExpressRoute? First of all, what I already said, automated system so that we don't need to take the physical fiber for all these customers, plug it into our data center and make it work. So make it automated as a service, right? And first of all, the reason is that if you go to any customer that wants Azure today, they want Azure as part of their network. They see it as, of course, it's public cloud, it remains public cloud, but they want to use it as they're sitting on top of this server, or sitting on top of this database. They want low sub-millisecond latency, they want great manageability, they want dedicated connectivity. So if you look at, there are 3 options basically to extend your network into Azure, into any public cloud. The first option is just to take site-to-site VPN. Of course, the first option is just use public internet, but okay, that's one option. The second option is to really go for a site-to-site VPN. You set up a layer 3 connectivity, you have a shared key on both sides, they interchange the connectivity to set it up, and it's pretty easy to do. It's basically next finish. I have an IPsec tunnel between Azure and my home telnet line, so it's really simple to do. It's 4 ports that you open in your router, and it works. It's not more than that. But exactly as the previous talk, you don't have any guarantees on latency. You don't know how many hops there are between your traffic. It goes fast, sometimes it goes slow, sometimes the latency is only 12 milliseconds, it's much more. Also, the bandwidth in this is capped, so the maximum bandwidth that you can get today in Azure is 200 megabits. It's not bad. So I would say that for a lot of dev tests and starting scenarios, this is already a great solution to get started with direct connectivity. The moment you move, you really need more speed, better latency, and you really go for production workloads or more strong workloads. This is where ExpressRoute comes into play. Now you have 2 options. They're still called the old way, but you have it in exchange provider and network service provider model. It's basically Ethernet versus IPVPN. That are the 2 models. In the past, this is how we called it. It's exactly the same. Or you ask your physical provider to have a layer 2 connectivity extended to you in a point to site way, or you expand your network using MPLS type of thing on layer 3. These were the two options that you had. And this is how it looks. Or you have a point to site VPN between your site and an ExpressRoute location, or you add the ExpressRoute as an extra leg onto your wide area network, like any other provider can do. So these were the three options that we had. And would they do that? It's basically to go hybrid and to have everything they're running on premises, virtual machines, backup, whatever you can imagine, and basically straight into everything Azure has to offer. Now that is where ExpressRoute really comes into play. Not only virtual machines, it's many services. It's about backup, it's about platform as a service, it goes about Internet of Things, machine learning. There are around 40, 50 different services that you can use to optimize your business outside of the normal infrastructure workloads. And this is where it's going to need ExpressRoute. If you look at the site-to-site VPN option, which I just mentioned, great option, but only works for infrastructure as a service. It's really for virtual machines, expansion of the hybrid capabilities. But the moment you start using the public services like websites, Azure SQL database, these platform as a services, you cannot do it through a virtual network. So moving on, want then to look at why is the ExpressRoute valuable compared to a site-to-site VPN, is because you get, first of all, predictable performance. It's a small differentiation in words, but it's very crucial. We never guarantee you that this is the performance that you can get. You can never go faster than the speed of light. And it's also not Microsoft giving you the SLA on the latency that you get between your location and ours. Responsibility. So like Peter just showed you, he can give 3 milliseconds on the first link and 5.5 on the second link it was. That's their responsibility. It's their SLA. The SLA, which comes from Microsoft side for the performance, is the moment the traffic enters in our data center on our network up until your services. That's where we come into play. So never forget that if you design your architecture and you implement these types of services, that you take these service level agreements into account and that you really know which part is responsible for what. Then, of course, about security, it's layer 2, so it does not go over public internet, so it's a private line. So security-wise, it's okay. High throughput, you can get up to 10 gigabits in speed, and even you can combine multiple circuits and then take as many 10 gigabit circuits as you want. If you have plenty of money, that's a great option. And then the lower cost, shouldn't say this in the recording, but it depends, right? Lower costs, let's look at it from a total cost of ownership point of view, not at really the cash that you have to pay for a 10 gigabit line. Virtually, it's not cheap, but the lower cost is more from the total cost of ownership side. You get all these other values and all these integrations, and that's where the cost aspect comes, which I don't fully agree with, but that's my opinion. Now, why do you do that? Is to get a private connection between your data center and Microsoft. So from a logical view, this is how it looks like. You have your own network. You're connected to a network of a partner, like Colt, basically with fiber, with Ethernet, with whatever. And they have dedicated connection with our edge, so with our routers. So the routers we have are patched straight into theirs, and they are connected through Ethernet, low latency. And basically this traffic is going to flow from your network through the edge of the partner edge network and straight into all our services. Now, I clearly talk about our network and not about Azure. So it's called Azure ExpressRoute, but actually what it does is it extends your network into your network, not only the Azure network. It's really the edge of our data centers. So basically it works for Azure. That's what we call private peering. So for infrastructure as a service, we can put public peering on top of it, which means that we can enable direct connectivity for any platform as a service. So Azure SQL database, storage, even SQL database, any service that we develop is accessible that way. And we even offer it for Office 365. But I have a slide dedicated on this because it needs some attention. If you want Office 365 and ExpressRoute, there are some points to keep in mind. I'll come back to that later. Now, this is a summary of the 3 connectivity options: or through internet, site-to-site VPN. Point-to-site VPN is also still possible. Point-to-site VPN means I install a VPN client on my machine and I have my machine connected into Azure. It's great for testing or whatever. And then, of course, if you go for mission-critical applications, there is only one valid path, and that is ExpressRoute. Now, for the scenarios which we hear a lot, it's basically to look at anything which is regarding backup, disaster recovery, everything which is around dev test. Developers want to have their development machines running in the cloud, and they want them accessible as fast as possible, like they're on it. They can remote desktop on that machine, like it is their machine under their desk. It's a pretty common scenario to use for the cloud. BI and big data. How do you ship big amounts of data into the cloud if you only have 1 megabit of speed? There has been, it's a funny story, but there was a big customer in the Netherlands who wanted to upload 2 petabytes, and they took 28 weeks to do so. So it was kind of funny. So it takes some time, but this could speed it up. What if you would like to do real-time streaming video on demand, and your origin of your media is not in the cloud, but is on premises, which is pretty common? Hybrid, and of course productivity. These are 2. How can you, for instance, keep your database on premises for compliance reasons, but still benefit from the cloud in terms of scalability and whatever? These are typical scenarios that you can see for these for ExpressRoute. Now, looking at how we designed the networking stack. So I'm not sure who was at my as a session on networking. So it's a little bit a recap of what we discussed there. It's about the networking stack as such, because it's valuable to know what the points are there just in high level to see how it fits into the ExpressRoute story. So basically, it comes back to this. You have the opportunity to bring your own network into the cloud. So we don't restrict anything there. So you have the full flexibility in bring A, B, or C class networks. So 10, 172, 192. Full flexibility in designing your own subnets and managing it completely. There's no restriction on which IP ranges you can use. It's completely isolated per customer. And you have the flexibility to configure high availability, your routing, everything you want. We offer you load balancers as a service, both internal and external, free of charge even. We offer you geo-distributed load balancers so that you can have a global load balancer for the full Azure platform so that you can load balance traffic around multiple data centers worldwide. You can set up your own firewall rules, your IDS, IPS, intrusion detection, intrusion prevention systems. You have the full flexibility to have multiple network interface cards per VM so that you can have a machine with 16 NICs basically and do all crazy stuff with them. And then of course you have full flexibility to choose site-to-site VPN or ExpressRoute, or even combine both. So you can, for instance, say ExpressRoute is my main, but I still use site-to-site VPN for some non-important traffic. Imagine that, for instance, you have a workload and it's not crucial in your business, like for instance, taking a backup. It needs to happen, but I don't want it to consume my main critical line in terms of bandwidth. You can still do so using backup lines, using site-to-site VPN or anything. Now, looking at how it has been designed. So this is how a classical network design for traditional data centers compares to how a public cloud like Azure designs its networking stack. So if you look at traditional classic design, it's mostly based on layer 2 with a lot of hierarchies, with a lot of physical hardware, a lot of manual work. If something new was needed, somebody needed to put in a new switch, a new router, or whatever, patch it all together, a lot of cables, crazy stuff. While if you go to hyperscale, this is not feasible anymore. Everything has to become software defined. So it all has to move into, first of all, automation, which means that everything has to be provisioned automatically, like port provisioning, bandwidth provisioning, whatever. But also the switches and the software that's basically doing the fabric of your network traffic, has to become software as well. So that's a software defined networking part of how we are designing it. And you have probably read that we are investing quite heavily as Microsoft to get these components up to the highest speed possible. And the only way that we can achieve this lightning speed is because we're moving more and more of these workloads into FPGAs. So anybody who does not know what an FPGA is? It's a programmable gateway, so it's basically hardware, a chip that you can program with instructions, so that it's not software that is executing this routing and switching logic. That's really a hardware component that is designed specifically to only do that, which means that this software can get up to 25 gigabits per second in switching capacity, which is much higher than any traditional switch that can do today. Plus the benefit that it can be deployed multiple times, full high available, full replicate, fully resilient, that if one of these components fail, that you have at least 2 other copies running of that same component that can take over immediately. That's how you design a hyperscale network. Now, coming back to this, this is the picture that you already saw before. Private peering, public peering, Microsoft peering. This is what I call the slide for marketeers. And I put it pretty small, not to offend people, but it's the slide for marketeers. It's how you basically propose what Azure ExpressRoute has to offer. This is not really how physically it looks like internally. Now, looking at a more technical view, this is more how it looks like. So physically, you have your customer network, and you choose yourself whether you do an IPVPN or an Ethernet connection, layer 2 or layer 3. That's what Peter explained. So you choose yourself what type of connection that you want, and basically you get into connected to Microsoft routers, connected to our backbone. And basically, all these routers have been deduplicated. So there are 2 routers on the partner side, 2 routers on the Microsoft side, all connected, fully redundant, so that in case one of these fails, that you still have connectivity. Now, this comes with a small catch. This means that if you are going to deploy ExpressRoute, that you need to deploy at least 2 physical connections as well to have the SLA and to have the uptime guarantee. Because what happens if you don't? You're not required to do so. You can take 1 physical connection, and if that one fails, it's broken, right? So that's why we say to get really up to the SLA and to really the requirements that we set, you need 2 times physical connectivity, which is a different play that if you go to your provider and say, I need 1 gigabit, actually you're buying 2 to 1 gigabit lines. Now I will deal more into detail how these virtual connections work, but this is more how it looks like. So this is what I call the slide for more techies. Now, looking at this connectivity, so we have the Microsoft side, we have the partner, and we have the Microsoft Edge. So all of this needs to be connected in some crazy way. So how do you link all these cans? So first of all, you have the choice to go to a partner location, like Peter has explained. So they already have the routers, they already have the capabilities, and basically they're going to hand off layer 2 to your network. That's it. So they have Ethernet to your building, and that's layer 2, and the rest is for you. So layer 3, the routing on top, it's something that you have to do yourself. That's one option. The second option is that you go for point-to-point, which means your data center straight into Azure. That is the model how Colt operates. So Colt has their data center point-to-point with ours. So they're in the middle and basically offering these capabilities. And then of course the MPLS side or the IPVPN side, which is called the layer 3. So you don't have to do the routing yourself. It's really a wide area network. Your partner is going to do the routing for you, configure all these crazy stuff that you have to do, which I will explain what you have to do in order to do it yourself, is going to do it for you, right? Now, this is the physical part. If you look at the virtual connectivity, when you provision an Azure ExpressRoute circuit, you have a couple of choices to make. First choice is, what type of connection would you like? Would you like a metered or an unlimited connection? The difference is metered, you pay a small fee, small base fee for the connection, and you pay per gigabyte that you use. That's a metered connection. An unlimited connection means you pay more, but you pay a flat fee. So you pay for that connection, and you will never pay more than that, whether you use it completely or not. One small tip, the tipping point between metered and unlimited is 60%. So imagine you take a 50 megabits connection. You can easily calculate how much bandwidth you can maximum push through it if you basically saturate that link completely during a month. Calculate that. If you are at 60% of usage, metered is cheaper. If you go above 60%, it's cheaper to move into unlimited. One small catch, you can move from metered to unlimited. You cannot move back from unlimited to metered. So your choice is crucial when you design your solution. Second option is you choose your speed. So we have 50, 100, 200, 500, 1 gigabits, 2, 5, and 10 gigabits. So you have full flexibility range of everything there is to offer. And these are in all models. So whether you do IPVPN or Ethernet, the properties are the same. Now, think about this. You can only upgrade the speed, you cannot downgrade, which means that you can go from 50 to 100, but you cannot go back, right? So something to keep in mind. You choose your connectivity provider, so you're completely free to choose whoever you want out of the list of all the ones we support. And you choose your connectivity model, layer 2 or layer 3, but that's completely unrelated to how Azure configure it. It's really between you and the connectivity provider. That model, and you define your service key, which I will show you. You hand it over to your partner, and they do the configuration for you. Now, there are two flavors in ExpressRoute. You have a standard and a premium one. So to explain a little bit, if you look at the Azure platform itself, it consists of geographies, geopolitical geographies, and regions. A region is, for instance, in Europe, Western Europe and Northern Europe, Western Europe being Amsterdam, Northern Europe being Dublin. We have 2 in the UK, 2 in Germany, and 2 in France. So that's around 8 regions. Now, what does it mean? If you, for instance, take ExpressRoute in Amsterdam, Western Europe, you can route traffic to Amsterdam and to Dublin because they belong to the same geopolitical region. It has been documented on our website what the geopolitical regions are, but it means that you can have one ExpressRoute circuit and basically route traffic to both sides. You have still one link, so it's not fully high available, but you can route traffic to both Amsterdam and both Dublin, which means that for disaster recovery purposes, you still have a good story there. Imagine that you would like to route traffic to every data center of Microsoft worldwide. You just activate the premium option. It's a small checkbox that you check, and it's an expensive checkbox, but it's a small checkbox. And basically what we do is we will allow you to route traffic not only to the data centers in your geopolitical geography, but also to every data center, every region that we own, which means that you can take a connection with Colt of 50 megabit, and you route traffic basically in standard to Western Europe and Northern Europe. By activating the premium option, you can also route traffic through that backbone, through the US, to Asia, to Japan, to any of our regions. And the catch is there, you route that traffic over the Microsoft backbone. So not on the Colt network. So Colt is basically going to put your traffic as soon as possible on the Microsoft core network and reroute it through our backbone. That's why you have to pay for that premium option. Now, the good thing is, I say it's an expensive checkbox. It only becomes expensive as of 1 gigabit. Everything which is lower, you pay a very small fee. So the fee for premium is basically depending on what the speed is of the circuit that you choose. So it's basically relative to the speed, because of course, with 50 megabit, you have less impact on our core backbone than with 10 gigabit, right? So the price point is set for that. Now, the good thing about ExpressRoute is also that you can share an ExpressRoute circuit. It's what we call the virtual component between multiple Azure subscriptions. So if you have a subscription for dev and for test and for production, you can have one Azure ExpressRoute shared between multiple subscriptions, even between multiple customers. But I will come back to that. I will show you how it works. It's pretty easy to do so. Sorry? I will come back to Office 365. There are some catches there. Now, if you are going to use ExpressRoute for private infrastructure as a service workloads, you need to have a termination point in Azure somewhere that can terminate your traffic. That's what we call an Azure Virtual Network Gateway. It's basically a virtual router that is going to terminate that traffic and route it to your virtual machines. Now, you choose yourself between standard, high performance, and ultra performance. Yeah, we're always very original on our naming, but the standard is giving you 1 gigabit. You can go to high performance 2 gigabits and the ultra performance 10 gigabit. And of course, that's all software, but the price is depending on the routing gateway that you need. So my recommendation is that if you are going below 1 gigabit, never go above a standard gateway. It's going to be wasting a lot of capacity if you do so, right? So keep that in mind, design it properly. Now, one small thing, this is only for infrastructure workloads, what we call the private peering link. For public peering and Microsoft peering, you of course don't need this. If I go too fast, if I'm talking Chinese, all right, because I see everybody likes, or if there's steam coming out of your ears, then let me know. So you hear me talking a lot about peering, right? That's terminology in networking where you're going to have two parties communicate with each other. And we talk about private peering if it's about infrastructure as a service, so virtual machines, virtual network, you name it. Public peering for everything which is platform as a service within Azure, and Microsoft peering if we talk about Office 365. So the first thing, if you are setting up peering, and I will explain you in step by step what it takes, the first thing that you have to consider when setting it up is that we talk in networking about autonomous system numbers, ASNs, right? And whether you set up a private, public, or Microsoft peering, you have to select the right ASN. Autonomous system number, it basically is a number, a unique number that you as a company get, which basically defines which public IP range that you own. Pretty simple. Now, if you do private peering, we don't restrict you anyway. You just have to come with a private ASN, and you can come with any number that you want, except 65,015 to 65,020, which we pre-reserved for ourselves. All the rest you can take for free. Now, our ASN is 12,076. So just if you would like to know, that's a very interesting fact. Yeah. Now, for public peering and Microsoft peering, we have the requirement that you come with a public ASN, which means that you have to own an AS number, not a system number, in order to route traffic through our backbone. The reason for it is that we need to verify who you are, and that we can only do a number in the public registries like RIPE and all of their 6 or 7 big ones, where we verify whether that IP range is owned by you. Now, the good thing is that you can, of course, if you work with a provider, ask the provider number. That's, I think, what you guys offer as well, with their AS numbers, and use their AS number to connect to us. And that basically, they shield your traffic behind their IP range. It's not that you have to own it yourself, but just to explain you what's behind it. So that's the AS numbers. Just remember, I'm getting step by step. So secondly, there might be some requirements for you to do network address translation in that field. If you do private peering, again, infrastructure as a service, no, nothing is needed. You just come with your private IP range on-prem and your private IP range in Azure, and basically everything routes and everything is sunshine and rainbows. Only thing you have to keep in mind is cannot overlap. So the IP range used on premises cannot be the IP range used in Azure. So design properly. And I see people nodding like, yeah, that makes sense. Yeah, you cannot imagine how many customers I've visited who use a /8, which means that they have nothing left to do routing to the cloud. There are plenty of them. So it sounds logical, but still, it takes proper design to think about your expansion in the future with all these regions and whatever you would like to do, right? Now, for public peering and Microsoft peering, we have the requirement that your traffic is netted behind a public IP range, right? So you net all your traffic behind a public IPv4, and that's how basically we know that it's you. And that comes together with that AS number. So we verify that this is your AS number, that this is your IPv4 range, and this is the way how we know that you're the customer that you are claiming to be. Why is that? Because on private peering, honestly, we don't care. It's your virtual network, it's your virtual machines. If you screw up, it's your mistake, it's your network, you cannot do anything wrong. In public peering and in Microsoft peering, these are all multi-tenant services. These are services that not only you are using, but all of our customers. If you have not, we need a way to make sure that you are the guy who are you claiming to be, that we can authorize you, and that's the way how we do it. That's to make sure that we do this traffic. Now, why do we do nothing as well? It works this way. So for private peering, you have bidirectional communication. I will come back to that later as well, which means that your customer network can send traffic to Azure, and Azure can send traffic to your network on premises, which makes sense, right? Now, in public peering, it's unidirectional. So you can only send traffic into the Azure platform as a service, but not traffic back. Why is that? Makes sense, because imagine that another customer would, in a multi-tenant scenario, use some service here and would be able to connect into your network. That would be a little bit crazy. And that's why we basically do NATing. And it's in network terminology, we do source NATing. So basically you have a NAT pool, which contains all the IP addresses on which you NAT. We check, you do a source NAT session, you open it on your router, you connect to our router, and basically if we want to send traffic back, we verify whether there is an existing source NAT session. If there is none, we just terminate the traffic, and we can never originate traffic from the cloud to on-premises. Now for Microsoft peering, we require the same, but Microsoft peering has bi-directional capabilities. So for instance, for people who are in that field, ADFS, if you use ADFS for authentication with Office 365, it needs to link back into your network, so that's why it's bi-directional. Now this all sounds nice. You make two parties communicate with each other. In networking, you have two options. Or you configure a routing table, which basically every party knows all the IP ranges of all the other parties where it can route to. Crazy way, if you talk about the internet, basically. Or you can use the border gateway protocol, which is BGP, is basically how internet works. And it's like two sides of the chain, network A and network B, whether it's Azure or whatever, but it doesn't matter. Talk to a BGP router, and the BGP router basically knows this is my network, this is my address range, and he's announcing it to all the peers that are connected to this router, and he's telling, look, these are the addresses, spaces I know. To me, you can do it on these addresses. And the other party does exactly the same. So the other side says, and these are the addresses that I know, and basically the routing table is automatically created, automatically refreshed, which means that every time there's a new service added, a new virtual machine created, it automatically gets announced through BGP, through all the routers that are connected on the same BGP session or the same peering. So pretty simple model, basically. Not that simple to create, but it's a simple, theoretically, it's a simple model to have network equipment communicate with each other. So it's fully based on BGP. And so basically what it does, it's two routers basically agree which traffic they accept and which traffic they can exchange on which IP ranges. And there is a BGP session created between these two, and that's what we call the peering. So for private peering, public peering, and Microsoft peering, basically what you're creating is a BGP session between your side and the Microsoft side. Now, in private peering, to step-by-step look at how it's configured, basically you have your network and you have your virtual network in Azure. So the first thing that you do is you create your gateway. Like I said, the virtual network gateway, standard, high performance or ultra performance, you choose yourself. Secondly, you're going to, you have the capability to set a default route, so something to keep in mind. So what happens if you announce the route on your gateway 0.000/0, which means everything, the default route, it means that all the traffic will be routed back to on-premises, which is possible. Careful with that. Then you can even set up a second virtual network, same subscription, different region in the same geopolitical geography. Imagine this one is in Western Europe, this one is in Northern Europe, and link it to the same ExpressRoute circuit, and they start communicating with each other. Now, the cool thing is that these gateways are also BGP capable. So every IP that exists in this network, so every virtual machine that gets created, gets automatically announced to the BGP gateway in Azure. This one announces it to the BGP router of the Microsoft Edge, which announces it to the BGP router of your provider, which announces it into your BGP router on premises. So there are a lot of steps, but that's theoretically how it works. And then, of course, if you still want to, you can still use a site-to-site VPN as backup, as a backup line for non-crucial workloads, for instance, that you can still route traffic that way if you think it's not vital in your setup. So that's private peering. And the gateway is the gateway that you define, subnet IP. It's a private range, like I said, ABRC class. But remind, if you design this, it has to be at least /28. And if you do public peering and Microsoft peering, at least /27. So you're losing quite some IP addresses in your range specifically for this. This is for routing because every peering uses a couple of IP addresses to exchange this info, to set up this routing, to have this BGP configured. So that's why don't forget /28/27. Now looking at public peering, so unidirectional, like I said, only from you to the cloud, and you hide yourself behind the public IP address, and we verify whether there is a source NAT address. And for the Microsoft peering, it's exactly the same, but for Office 365, you need premium. Premium is a requirement because there are some ways that Office 365 is designed as a global multi-tenant system, which means that though I'm a European customer, I can still be connected to a front-end node in the US, though my data is in Europe. So that's why you need a premium add-on for writing capabilities, and you need specific authorization from Microsoft. So you cannot take a Microsoft peering for Office 365 without pre-approval from Microsoft. So the reason is that we first want to make sure that first of all you did a network assessment to make sure that it's really needed to optimize your flows, that there is a compliance reason to do so. My traffic can never go through this country because of whatever reason, and it needs to go that path. It's a good reason. And the third reason is that you want to do quality of service in some way for Skype for Business, for instance. These are the three valid reasons to implement it. Now, the reason why we do it with pre-authorization is because we have seen many customers that think it's software as a service, but suddenly everybody wanted to have it on their network, which doesn't make sense in a lot of cases, because what problem are you solving? So that's why we say before you deploy it, pass by us. We have a process for that. We will review your case. We will do a network assessment together with you. We will propose you whether this is a good solution or whether there are other solutions possible. Another catch, which many customers forget, if you deploy the Microsoft peering, you still need internet connectivity. So some thought, oh yeah, I can use Office 365 from internally. I don't need public internet access anymore on my routers. Yeah, but you do. Why? Because DNS and CDN is never routed through ExpressRoute. So fetching DNS and looking up where the Office 365 tenant is, for instance, and downloading client downloads for Office, for instance, Office 2016 Professional Plus, it's a CDN download. It will never go through ExpressRoute. So imagine that you have disabled, that you have connected it, and you don't have public internet connectivity in your network. Basically, full Office 365 will be broken, and you have no clue why. Again, that's why pre-approval, right? And lastly, it's bidirectional. So you can send data into it, and it can receive communication back through SNATing, and that's, for instance, ADFS is a good sample why, for instance, also video, like there are many different reasons for this. Now, I've talked about this NATing as well. I will skip this. Now, looking at routing, there's also, of course, you hear me talking, and this is getting the fun part, about you take a circuit to one location. So for instance, I take an ExpressRoute, like Peter showed you, into Amsterdam, which means that I can route traffic to Amsterdam and to Dublin. But I still have one connection. Though it's two physical lines, it's one point, which means that it can fail. Something can go wrong. Imagine that the edge in Amsterdam blows up. You're screwed, right? So what would you do in that case? You will enable multi-path routing, which means that you will take multiple ExpressRoute circuits and have one ExpressRoute circuit linked from your premises into Amsterdam and an additional circuit from your network into Dublin. So basically you're taking 4 physical lines. And if you talk about the big customers, most of them ask non-parallel lines, which means that they can never intersect in any point. They have to be at least redundant, and really the big companies even ask it has to be deduplicated over 2 providers at least to make sure that there's no single point of failure in any of these topologies, right? So this is how you do it. For instance, you have your office in Los Angeles and an office in New York. You have your virtual network in West US and a virtual network in East US. And basically, you're going to configure everything routed to each other. So you have an ExpressRoute in Los Angeles, an ExpressRoute in New York. Then all the gateways are connected to both sides. So the gateway in Los Angeles is connected to both New York and Los Angeles endpoint and so forth, which means that you have a kind of mesh network. They all exchange BGP, which means that this would die, traffic would still flow, right? Now, this is great, but yeah, is there anybody who sees a problem with this setup? So that I can take another drink while you guys think. There is a small problem in this setup. It sounds great, but there is a small issue that you don't get if you do it like this. Yeah, you have to pay, that's true, but that's not an issue. That's a good thing. Well, the two data centers, these two, are basically linked through the ExpressRoute backbone. They have direct connectivity as well. Yeah. Every virtual network that you attach to an ExpressRoute circuit belongs to the same routing domain and can communicate other, right? So if you have 10 virtual networks all assigned to the same ExpressRoute circuit, they can communicate with each other as if they would be part of the same physical switch. Now, what you can't do in this setup is you have no idea how you do, if you do it like this, no control how your traffic flows. So how do you know that Los Angeles is the closest to West US, that the traffic goes this path and not takes this route? You don't in this setup because it's BGP. So you have absolutely no way in making sure that this traffic, except if you make an additional configuration and yeah, this is and that you're going to do paths, and that's what we call multi-path routing. And at the moment you're sending traffic, you're going to basically influence the path that the traffic can take. And the path that you take is basically, again, using autonomous system numbers. So every network has an AS number. By tagging that traffic with the correct AS prefixes, that BGP-wise, it will route the correct path, which means that it will take the shortest AS path to go from there to there instead of going this path. So basically, the cost of this link is 1. The cost of this link is 2. So basically, it's smart enough to, by default, take the link with cost 1, except if there is an issue with that link, it will fall back to the link with cost 2. Right? So that's based on these AS numbers. Now, the cool thing is that every data center, every region that we have has a unique number assigned. It's documented on the site, which means that you can influence routing and say, I always want this type of traffic to be routed to Dublin straight or from Dublin into, and that's all by these AS numbers. So we have published them online so you can do it that way. Now, this is the way how it works, and ExpressRoute is smart enough to send traffic to the shortest path possible if that path is available at the time of routing. Now, this is basically how the traffic would then flow, except if that line would die for some reason, it will automatically learn that the shortest path has been gone and that this is the new shortest path, and you see it will take that route as well. So that's the cool thing. Through BGP and through all these peering, it learns itself which routes are available, which are not. It looks a lot like Skynet, right? So how does this prefix advertisement work? So it's, I think, the biggest challenge in implementing ExpressRoute. If you do all 3 peerings on private peering, you get the prefixes that exist in your network, which makes sense. If you have a block of /24, you can announce 16 prefixes to on-premises, which is okay. If you do public peering, you get all the prefixes announced which are in our domain, which means that 2,000 plus routes that get announced through BGP. Now, people say, yeah, but why don't you group them and make one? Because we buy so many IPv4 ranges that there's no way to structure them all under one route because we buy them all the time. And that's why we announce very fine range routes, sometimes even /30, which is a single address. So it's very small. That's why we announce 2,000 routes. If you do Microsoft peering, it's an additional 500 routes, which means that on your edge router, you have 2,500 BGP routes announced. And I've seen many customers that say, yeah, we have BGP routers, but our router is not capable of dealing with this amount of routes. It's a challenge because you need significantly powerful infrastructure to be able to get 2,500 routes into your BGP. Because what happens if you exceed the maximum number of BGP sessions, routes that you can have, basically the connection blows up because it will reject these paths and it just doesn't work anymore. So it's kind of crucial to design it properly and to monitor how many of these prefixes that you have already announced. Now the cool thing is you can, for instance, say allow and reject. Yeah? That's something that you can control on your network traffic. So that's what I say. Every data center has a tag received. So for instance, 12.676 is our AS number, semicolon, and then the number of the data center is basically restricting the number of routes to only, in this case, Microsoft peering, I don't know by heart, but to only Exchange and SharePoint Online. So you have the flexibility to, for instance, say, I'm only interested in the prefixes from SharePoint Online and Exchange, but not for Skype for Business, not for CRM Online, not for Power BI, whatever. Which also means that your router will only be able to route traffic to Exchange Online and to SharePoint through ExpressRoute, and all the rest will still go to Internet. And that's your flexibility in making, imagine that Exchange is so crucial in your organization that you only want to route that through ExpressRoute and all the rest you won't. This is how you can do it. So the number of prefixes drops significantly. Secondly, for public peering, you can do the same. Every data center has its tag, which means that I can say, give me only the IP ranges for data center in Dublin, for instance. I don't need the others. I don't need Western Europe. I'm not going to use that. So basically, you have the flexibility to reduce this number of rounds from 2,500 to 300. But something that you have to configure, something that you have to do. So this was the easy part, the intro. Now, just to come back, if you think about one question, I will ask it myself, would be, when do you choose for layer 2 and when do you choose for layer 3? Pretty simple. Layer 3 will be more expensive than layer 2 on physical side, on cold side, no? Which makes sense because they just provide you Ethernet and you do all the rest. If you ask that your provider does all the routing and BGP, they need more equipment, they need more work, so it will be more expensive. Now, before you choose for layer 2, make sure that first of all, you're able to terminate layer 2 in your network, BGP capable material equipment in your premises that is capable of dealing with these routing prefixes, and thirdly, that you have somebody with the skills to configure BGP. If you're not complying to any of these three, forget layer 2. That's how it works. Or you hire a partner that does it for you, but you get my point, right? You need somebody that is able to configure this layer 3 on top of layer 2 for you. If you say, I don't have any of these, or I miss one of these, you go for the layer 3 option, the IP VPN, and your provider is going to do all these for you, and you never have to think about it. You just say, I need so much speed, for you. Oi. And they will do everything for you. So yeah, the TV doesn't like the advanced stuff either. So that's, for me, the most important choice to make. Layer 3, because we have seen customers making the wrong decision, price, and then don't realize that BGP skills and setting up full redundant network equipment and stuff is not the easiest thing to do, right? Now, to move on, any questions so far? Yes. Yes. I will come back to what, because it's indeed a good question. So, but I will when I do the demo, I will show you what you can do and what you can't. Good question. Now, advanced is many customers implementing ExpressRoute. We say it's more secure. Traffic on an ExpressRoute on layer 2 is unencrypted, right? It's layer 2, be more secure, but it's still unencrypted. While a site-to-site VPN with IPsec is encrypted end-to-end. So it's a small thing to keep in mind that your traffic is flowing plain text over you don't control. So what would you do? You can, for instance, say, I'm going to add some equipment into that chain. So network equipment, for instance, on Azure side and on premises side, and what most companies do to do encryption in transit is basically to do a side-to-side tunnel over ExpressRoute between a physical and a virtual device on both sides, which gets the benefit that it's still ExpressRoute, it's still 10 gigabit of speed, but you have full control on all these encryption capabilities. Plus, you can do all these crazy stuff like IDS, IPS, taping. You can do firewalling. You can do everything you want. So basically, you could even create a solution where everything originating from Azure to the public internet is routed through your backbone, routed through your IDS and IPS system, and then basically going to the internet traffic. So that's an option. Control, something that we don't impose, but remember that if security is important, that you have the flexibility to basically add it into your architecture in a pretty simple way. And you see there a couple of solutions like Cisco F5, Steelheads, Barracuda, Fortinet. I think today we have support virtually for any of these solutions. Any big vendor has a solution ready for Azure to be deployed as a virtual appliance, basically. Yeah, nice. Okay. Jumping names. Secondly, it's not that because you're having a 10 gigabit line that you cannot benefit from WAN optimization. So if you design a solution, it might be smart to use some WAN optimizer, which is basically going to reduce the needs for 10 gigabit and making sure that you can keep everything under 1 gigabit and still have the same capacity. And one solution that we see quite often is a Steelhead that we put there. And a Steelhead, for instance, is a WAN optimizer that will only send the blocks that have changed, which means that you've significantly reduced the traffic between both sides. And same for Office 365 and stuff like that. So that's also something that you can put into place to optimize your end-to-end bandwidth usage. And then, of course, quality of service. It's only built in for Office 365. So it's also one of the reasons why you would take Office 365 on ExpressRoute, this quality of service for Skype for Business, which is pretty difficult to do on public internet. So, but if you have any solution for quality of service, we today don't offer quality of service attributes on ExpressRoute, so it's everything gets the same priority, which means that whether you're sending email or whether you're doing a upload of a backup, it all gets the same bandwidth, nothing throttled. So if you want that, you have to put in a quality of service on both sides, virtual and physical, to make sure that the traffic gets tagged and gets priority over other traffic. And then, of course, forced tunneling, like I said, which means that every traffic originating from Azure Virtual Network, I'm going to force it back to the tunnel to on-premises. Basically, that's by announcing a default route. All the traffic will be sent back into your on-premise network before it's going to be broken out to the internet. Gives you a lot of flexibility to do IDS, IPS, SSL, crazy stuff like decrypting all the traffic, re-encrypting it, which is what big companies do these days. So remember, this is what you can do, but it's not that easy. It's a little bit more advanced. So it's your choice to set up these policies so that the traffic, like you see, flows the purple line through on-premises, monitoring, whatever, and to the internet, right? Imagine, people ask, yeah, but why would you do that? If you are in the enterprise, you cannot go on Facebook and Twitter and how can you do that if a developer can spin up a virtual machine in Azure? Basically useless, right? So how do you fix that? Forced tunneling. And even if it has a virtual machine in Azure, its traffic will be routed to premises and it will be same applied, the same reverse proxy, same transparent proxy will be applied. And he thought that he was smart, but he's been, outsmarted again. So now I will show you a demo, except if there are still some questions. Any doubts, unclarities, things that I said that you think doesn't make sense, or everybody's still awake? Yeah. Yeah. Mm-hmm. Yes. Yes. No. 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 It's a separate license. The reason we decided to do so is because most of the customers that are looking at ExpressRoute already have contracts with an F5, with Palo Alto. They have already these physical appliances or virtual whatever, and they have license portability, so they can use exactly the same license. And their management console managing their solutions on premises as the ones in Azure as well. So most of the time, it's just porting licenses, nothing more. That's why we say we don't do so. We, of course, offer firewall capabilities built in, but these are pretty limited compared to what you can do with these big guys. So that's a little bit the answer to that question. Mm-hmm.
And then it routes from the private part to the public and Microsoft part, or from the services.
No, so it will. If you place a firewall, it will always be your virtual network, and if you, for instance, require encryption or one optimization for public peering and Microsoft peering, it's something that you have to ask your provider to do so, because they have only access to the physical, to put it in the physical location before it enters our edge. So you cannot do it yourself. You cannot go into Office 365 and say, for private you can do it yourself. For public and Microsoft peering, it's something that the provider does the moment the traffic enters our edge, before, not right before. Could be, yeah. Depends. Some of them offer it already. It's pretty hard to say all of them work it the same way, but that's indeed how it works. Yes. Yeah, it's a little bit placed wrongly there. Correct, yeah. But it's still possible, but in the case of public and Microsoft peering, it will be in the data center of Colt, for instance, while in the private part, it will be your virtual network. Still the same principle, but that's how it works. Now we'll show you how you configure all of this. It's pretty straightforward. In the past, it was PowerShell fun. Now it's not, so it has changed. So basically, you go to the Azure Portal, the new portal. No, actually the new portal, and you create the new, and ExpressRoute has been added as a new service. So basically, you take ExpressRoute, okay, and you say, okay, let me create an ExpressRoute. Create. Through PowerShell, it's still faster, but visually how it works. You create your circuit, you give it a name, and you see immediately an option to create a new one or to import an existing one. Import is, imagine that you're still running ASM, the Azure Service Management API, so the old portal, and you would like to recover that existing circuit and move it into ARM. You just to import, and it will import that existing configuration to a new ARM-based ExpressRoute config. But for a new one, you just call it whatever you want. You see, and I'm going to quickly open Zoom it so that you can Zoom it. Favorite Zoom it. There we go. So basically, second part is that you provide which provider, you select which provider, and these are all the providers that are offering ExpressRoute in some form today. Now, crucial is, you see this list, for instance, there are providers that don't specify whether to do Ethernet or IPVPN, so that's between you and them. We don't intervene between you. For instance, Colt has decided to make it clear between both and to say Colt Ethernet, Colt IPVPN. IPVPN layer 3, Colt Ethernet layer 2. So you choose your provider from this list. Okay, there we go. Ethernet. And you choose your peering location. And in this case, these are the locations that Colt is offering ExpressRoute. Now, I think these are the locations that you mentioned before as well. So Amsterdam and Dublin, London and Tokyo. Now the cool thing is, you choose yourself. Of course, you have to tell them as well which one you choose. Now the good idea is, which is closest, first of all, to where you are. Makes sense. And secondly, closest to are planning to deploy Azure services. So don't take Tokyo if you're going to use Azure services in Western Europe. It will work, but it will be not the smartest choice ever because you cannot change this anymore. It's one time. So I choose Amsterdam. You choose your bandwidth. There you go. And of course, based on the provider definition, it could be that some bandwidths are not available in this list, right? This limits the bandwidths to the bandwidths offered by the provider. So it could be that some providers only offer up to 1 gigabit. It's possible. Then you will see so. You choose your speed. Choose your SKU. SKU, basically the plan, standard, premium. You choose your billing model, unlimited versus metered. This means that you can still use the ASM API to use the ARM VNet. You put it in a subscription in a resource group and that's it. So it's pretty straightforward in the number of parameters that you have to give. Small catches. You can change from standard to premium anytime you want. So it's not something that you have to decide right now. You can change from metered to unlimited, but you cannot change from unlimited to metered. So basically, makes sense. Like I said, if you reach 60% of usage, it's smarter to move into unlimited, but we don't allow you to switch back. Secondly, you can switch from bandwidth up, but not down. Go for 50 to 100 to 200, but not down. Now, one small tip that I will give you. If you provision ExpressRoute, the moment I hit create, everything in, I use my, that's it. This is the location where it will, where the ExpressRoute circuit is basically built. It's not where it's split, right? It's where my billing will be occur. The moment I hit create here, it will create my circuit, right? Now, think about the lead time for deploying ExpressRoute. Been talking to code guys. In the past, it was around 6 to 8 weeks. Has been reduced to 4 weeks with a cloud, with an on-demand platform like Colts and some others. You can reduce it to 10 days, right? But it's 10 days that you pay for a capacity that you might not need. We have seen projects. I've done a pretty big one where it took, where due to some hardware that we needed to ship and you need to shovel a hole to put new fiber in, it took 3 months. If you imagine that you create a premium circuit, unlimited, and you take 10 gigabits, and it takes 3 months, might not be a smart move. So what I always recommend is start with metered. If you deploy, start with metered, 50 megabits. It's on so 50 megabits standard metered. You can always point. The cost for this will be 20, 30 euros, something like that, because the base fee, there's no traffic flowing, so the base fee is almost nothing. So that's my key tip in being successful with ExpressRoute. And make sure that that basically these 3 months are almost for free. And the moment your 1 gigabit circuit with your provider is delivered, you switch to 1 gigabit, you switch to premium, you might switch to unlimited, and you start paying the day you have your service. Create. That's it. That's all what you have to do. So it's now being provisioned. It will probably take a minute, maximum 2. And then I will show you what you can do. Now, the challenge is I cannot show you how you basically configure routing because, of course, the next step would be it will now generate my ExpressRoute circuit. Yep, deployment started. The moment my ExpressRoute is done, I will receive a GUID, which is called my service key, which is my unique identifier for me as a customer. I give that service key to my provider, and they will do the connection. That's what the demo you saw in the first part. So they're on-demand portal, you plug in that GUID, it will activate all the physical stuff, and the Azure portal will get a report back that on that service key, the end-to-end connectivity has been done. That circuit comes into enabled state, provisioned state, and then I can start configuring my peerings, right? Deployment succeeded, so if I go into my ExpressRoute circuit, so get an overview, and you see here, provisioning state, not provisioned. So as long, and this is my service key, so as long as I don't give my service key to them and they do all their physical work, this is going to be useless, right? So that's the first step. And now you see these 3 peerings have been there but are still disabled. And the moment my circuit is provisioned, I can start doing my work. Now, what can I do? So if I go into the Azure Private, the steps that you need to take are the same for all three. I will walk you through it. So you see the circuit is not provisioned, so I cannot do it right now. But sorry? Yeah, but it's a demo portal, I think. I asked, but I don't think we can do it on the production side because. So you see the parameters are always the same. I have to enter my autonomous system number. Like I said, any except 65,015 to 20. So this is private peering. For public peering, I have to come with a public AS number. And something strange here, I have to enter a primary subnet and a secondary subnet. It's a little bit confusing. People are not used to configuring this, don't exactly know what this means. So actually what happens, if you remember, we had two routers on your side, the provider side, and two routers on the Microsoft side. Now these routers mean IP address. That port needs an IP address. That's this subnet range. So basically, you plug in on both sides. So you put a /30 on your primary, a /30 on your secondary. The first address from your /30 will be assigned from the primary. It will be assigned on the primary router of you, at gold. Okay? The second IP in that /30 range will be assigned to the router at Microsoft. And for the secondary, the same, but for the deduct infrastructure. Actually, in the past, it was 1/29 that you have to give, which we split it up into /30s, but it's easier to think about that. If you do private peering, it can be a private IP range, private /30, but it cannot overlap with any IP address or on premises or in your VNet, because if it, then the routing would basically blow up. In public peering, it needs to be a /30 times 2 on a public IPv4 range. When you are a company and you don't have enough public IPv4 addresses, you might be in trouble, right? So it's all to keep into account, which means that a /30 has basically 4 addresses that is used. So basically you lose, not really lose, but you need a lot of public IP addresses to configure this. For Microsoft peering, another range. So the range used for public peering cannot be the same range as range for Microsoft peering. It has to be 2 different ranges. Then you enter your VLAN ID. You can choose any ID you want, but you cannot use the same ID for different peerings. So every peering has its own VLAN ID. That's basically how the traffic gets stacked with the VLAN ID, so that it knows how the traffic gets routed internally. And then you have something which is optional. Shared key is basically a key that you plug in, which is used to do MD5 hashing of the traffic which is originating on BGP, so that it basically can verify that the traffic is basically, that takes an MD5 hash, it compares it with the key, and it can verify that the traffic is correct. But it is optional. If you don't want it, you can leave it blank, and it will still work, but it will not do these MD5 checks. If we go into public peering, you will see that it's exactly the same steps. Same steps. There we go. So exactly the same, but a public IP range, right, which we have to verify. And for Microsoft peering, it should be, well, but for Microsoft peering, you can basically have an extra field, advertise public prefixes. This is basically a place where you can, because it's bidirectional, where you can prefixes that you would like to announce to Office 365, like where's your ADFS, stuff like that. And then your routing registry name is strange that it's only here, it should also be with the other, where you can specify which race your AS number is being registered, RIPE, or any of the others. For the rest, it's exactly the same. The moment your circuit gets provisioned, you go in there, you fill in your parameters, you hit OK, and your peering has been set up. Of course, you still need to do BGP Matic on premises, or your provider or yourself, but Basically, that's how it works. Imagine that your peering has been set up, your 50 megabit is working, and you would like to go above. Then you go into configuration. I'm not going to do it because for some reason this page is not working today. Configuration, and you can change any parameter like I just showed, from standard to premium, change your bandwidth, change from meter to unlimited, but not back. And the last thing, which is cool, that you have an ExpressRoute circuit. You are the admin in your organization, your network guy, and you have provisioned your ExpressRoute circuit. And now suddenly a guy says, yeah, I have my own subscription. I would like to hook up to your ExpressRoute circuit. Can happen. Huh? So you have authorizations, which means that I can invite other people to my ExpressRoute circuit. It's great if you are, or if, for instance, imagine you're a partner, and the question right before this, you're a partner and you have you manage a virtual network with ExpressRoute for your customer, and the customer defines his own virtual networks, and you would like to hook them up to your circuit. Basically, you can give him authorization to use that service key. We use it. So how does it work? I name this customer. I do save. And this is going to create an authorization for anybody who uses the authorization key in combination with this resource ID, can basically, in his own subscription, though that subscription might not be ExpressRoute, can still use my circuit to connect to my backbone, right? Now, there's one small catch. Again, there are a lot of catches today. So you see, that's the key, and that's the resource ID. And how does it work from, if I'm the one who receives it, I go to add, say connection, which is the connection between an ExpressRoute circuit and a virtual network. That's how it works. I say connection, and then I can, there should be an option, claim authorization. I normally do it through PowerShell, but let's see. There we go. ExpressRoute. Okay. ExpressRoute. So I'm now configuring a connection between my VNet and ExpressRoute circuit. And there will be here an option, redeem authorization. The authorization key, the connection name is that ID. And the peer circuit URI, that's the peer circuit URI is that resource ID. And the connection name is just the name which I would use. So that's how I connect from a different subscription or even a different customer into a circuit that exists. Now, one thing which happens quite often is that people say, this is interesting. Imagine that I'm a partner, a hosting company. I buy an ExpressRoute circuit of 1 gigabit, and I'm going to resell it to my customers in this way. Worst idea ever. Why? If you do this, every virtual network that you link to the same circuit in this way belongs to the same routing domain, which means that without any firewalls in place, they can route traffic, which means that if you as a hosting provider would use this and hook up multiple customers into that same ExpressRoute circuit, suddenly customers can see data from each other. IP ranges can conflict. You can get, it's crazy. People have tried it. People have failed miserably. What you can do, physically, you can do so. So you can, for instance, go to guys from Colt, say, look, I would like to buy 1 gigabit, and I would like to provision ExpressRoute circuit for my customers that I, as a hosting company, are doing. So I buy a physical one of 1 gigabit, and for instance, a customer comes to me, say, I need 50 megabit. Hey, you call these guys and you ask them to create a new VLAN for you, and basically you have a VLAN within your physical pipe, specifically for that customer, but a service key per customer, an ExpressRoute circuit per customer. In the future, with the on-demand story, you can even do it fully automated so that you will go to that portal and say, I need a new VLAN, that's my new VLAN ID, I need 100 megabits, and magic will happen as well. So that's the right way to do so. Physically, in multiple VLANs, because networking-wise, multiple VLANs cannot communicate with each other, so that's how you properly do it. The second option, using one virtual circuit for multiple customers, stay away from it. It will work, but it's not supported. If you have issues with that, we will wish you a lot of success. Is that clear? Right? So this is physically, and BGP is a difficult part. To configure it on the Azure side is pretty straightforward. Now, what's next? So, except there are still questions before I. Yes. No. Commercial. Mm-hmm. Technically, there is no reason. No. Mm-hmm. Mm-hmm. Yes. In the past, let's say half a year ago, you could downscale, but they recently changed that. Don't ask me why. Now, what's next? Imagine that tomorrow you get home, or this evening even, and you think, I would like to have ExpressRoute. Today, it's even possible to get ExpressRoute to your home. It's crazy, but it's possible. I've asked, and it's possible. If there's one slide that you need to keep that I will ask Martin to share, because I will not share my slide deck as is, because it contains quite a lot of content that is not shareable with the big public, but this slide I will. So first of all, think about which workload are you covering and what bandwidth requirements do you need. Site-to-site VPN might be an option, might be a good option. You might get good direct internet lines as well from a good provider. Might be a good option if you don't need these low latencies and whatever. What's good? Design your network topology. Like I said, think about what is my network today? How would my network look tomorrow? Globally, which address ranges would I like to apply? How does it look like? Think about that. Design your network about the application flows. Like I said, there is no built-in quality of service, so it's very interesting to think about, do I have? Is it your database? Is the database on-prem, a web server in the cloud? Why am I doing this? Good question. Think about disaster recovery. Have one single circuit into Western Europe. Is that okay for your business? Or do you need to duplicate everything? So 4 physical lines, 2 ExpressRoute circuits, or even more. So you can bundle multiple 10 gigabit circuits if you're really big. Their biggest customer today, I think they have 100 gigabit. It's already a big pipe. Choose your ExpressRoute data center, so the location and your partner, depending on where you would like to break out your connection. And like I said, build, test your setup properly. How? 50 megabit meters and standard, and scale up when everything is running and when everything is done, to lower your initial cost of the circuit. Don't expect from ExpressRoute that it will solve the speed of light. I've seen customers say, yeah, but I will take it because it will go faster than 1 millisecond. It's impossible. Speed of light between Brussels and Amsterdam will be around 160 kilometers, more or less, so it will be 1.6 milliseconds. That's why you saw Peter on his slide talking about 3 milliseconds round trip. That's around what you can expect from the speed of light. So don't think that but compare, if you go to a provider, ask them very clearly, what is the latency guarantee that you give? What is the SLA that you have to offer? Because there is a lot of difference between them. Not all of them offer 3 milliseconds. To be honest, I think the offering Colt has is pretty nice. I've not seen any other provider, not many, that give guarantees. Don't forget about encryption and security. Like I said, encrypted in transit, it's not by default, but you can do so. Don't forget about WAN optimization, and think about your SLA. So who is responsible for which part? Do you look at Microsoft or do you look at your provider? Very important. Don't connect multiple companies to the same circuit, except if this is what you want, of course. And don't underestimate BGP. Most made mistake, it's like BGP is easy, it's not. Right? So these are my do's and don'ts to do ExpressRoute partners. So we have been talking a lot about Colt, but there are of course plenty more. So we have a lot. Let's say that these are the global partners, but of course in Belgium, I think almost any telco is offering it as well. And somebody Nobody puts up his hand and said, yeah, where's Proximus? We're still not on this list. They have it. They offer it today. They're not on this list because there's a big differentiation between the global partners like these guys and, for instance, the Proximus and Telnet. They offer it as well, but they don't have the direct connection as Colt does. So Colt has direct connectivity between Microsoft routers and their routers. For instance, Telnet and Proximus today don't. The global players, they're local players, which is great for the local market, and they connect indirectly, or through Colt, or to Equinix, or to another provider, which is perfectly fine. But think about this as a whole. That's why they're not on this list. But everybody today, ranging from Destiny to Proximus, Telnet, Interaction, they all offer similar capabilities. Not all of them do both Ethernet and MPLS layer 3. Some do only layer 3, some do only layer 2. But ask your questions, and that will all come fine. And that was my part. So if there are no further questions, then I can only thank you for attending. I think I spent a little bit too long. Sorry for that. And then I can only say there are still plenty of pizzas, still plenty of drinks. So enjoy the rest of. Still a question. No. But good thing is, the recording will be put online, so I cannot leave you the slides as such, but the recording, how I presented it today, will be put on the Azure BE site. So, but feel free to reach out to Microsoft if you have specific topics that you say, how was this exactly? I share them privately, I one-to-one, but not one to whoever, because if I put them on Azure BE, I have no control who basically uses them, right? So, any others? So let's take some drinks. Thank you.